Hello, ladies and gentlemen. This video is all going to be about compositions and symmetry of figures, or compositions of transformations and symmetry of figures. So what you're going to need is your notebook or composition notebooks. There should be a little half sheet foldable from me. And if you don't have that foldable from me, you can always write them directly into your notebook. And then of course a pen or a pencil. So first, let's talk about what is a composition of transformations. The definition of a composition of transformations is when two or more transformations are combined to make that final image. So if we look at the leftmost picture, we're starting at this triangle, and then it looks like they're reflecting it over the x-axis, and then they're just sliding it or translating it to get that final image to be C double prime, B double prime, A double prime. So a composition is just like that, where from the starting image, if you reflect it, then we're going from this second image to the final image. Some people think when they do compositions of transformations, when they see like plot the points A, B, C, and then reflect it over the axis, and then translate it to the left. What some people would do is they would reflect it and then start at the starting image again, and then slide it or translate it, which is wrong. This is not what you want to do. You always want to go like, if this was your first one, then you use your second triangle to make your third triangle. So hopefully that makes a little more sense. So some of the problems that you'll see on homeworks and learning checks is they might ask you to draw out the composition, or they might give you a picture like this and just ask you to simply describe in words what happened from triangle 1 to triangle 3. And then, of course, there's some more examples over here. So if the middle one, it looks like we're starting here, and then because of the 1 prime, that means that's where we're going next for our second image. So they reflected it over the x-axis again, and then it looked like it was rotated to get to that third image. And then on the very right picture, I know it doesn't actually say where we started, but let's assume we start in the blue little arrow. Then we're translating it to this red one, which is the second, and then we're rotating it 180 degrees to get to that green one. So that is, in short, what a composition of transformations is. So now we're going to talk about symmetry. So there's two types of symmetry. There's line symmetry and there's rotational symmetry. So first, what is line symmetry? When an image can be reflected over or in a line, or if the image has a line of symmetry, it can also have multiple lines of symmetry. So I know that these pictures are not on your foldable, so if you wanted to draw them, you sure could. So when it comes to like homework problems or learning check problems or quiz problems, it might ask you, like if they look at this pentagon and they say, how many lines of symmetry does the pentagon have? Well, there's one here. We could draw another line of symmetry here. We could draw another line of symmetry there and there and there. So that would actually be 5 lines of symmetry. And then for a square, like over here, you could cut it in half like this. You could go from diagonal to diagonal. So that would be 1, 2, 3, 4 lines of symmetry. And then these last couple ones, if we were to cut it like this and fold that sheet on top of itself, would it create a line of symmetry? Well, not horizontally, but vertically, yes, it does. And then if you have a circle has an infinite amount of lines of symmetry, because you could constantly be drawing lines that cut into symmetry. You could keep going because circles have lots of special properties to make it so that it has infinite amount of lines of symmetry. So those are what lines of symmetry are. I'm sure you've seen these kinds of things when you've talked about symmetric, not symmetric, asymmetric, stuff like that in your previous math or art classes even. Okay, so now we're going to go on to rotational symmetry. Rotational symmetry is when an image can be mapped onto itself after being rotated about a center, which is typically the center within the middle of the image. So it has a center of symmetry is what we would say if a picture has rotational symmetry. It's got a center of symmetry. So one of the questions, or some of the questions that you'll see about rotational symmetry, is they may ask you, does the figure have rotational symmetry, like yes or no, like rotational symmetry, like question mark. It'll be like yes or no. And then if it says, if you say yes, like if yes, then at what degree? At what degrees is it rotationally symmetric? Oh, I forgot an E. Okay, so what we're saying is when an image can be rotated such that it's mapping back onto itself. So if you tried to visualize like this picture, like of a pinwheel almost, if we were to rotate like this part of it so that that part lands on, like if we were to rotate it so that it lands on this one or maps back onto itself, that's what we're saying. So like if this were to rotate so that it maps onto the next fan, if you will, that means that it's rotationally symmetric. So the first question would be yes, it's rotationally symmetric. And then the next question is, if yes, then at how many degrees? Well, there's 4 distinguishing pinwheels, or like 4 like special characteristics that are sticking out from that center. So what we're doing to find out what degrees, if you just think about it, like this turn is a 90-degree turn, or else how you could have found that is there's 360 degrees in a circle, because when you're turning in a circle. And then you're dividing by those 4 distinguishing features, which would get you every 90-degree turn is when it's rotationally symmetric. So let's look at the next one. I'll do it in a different color so that I don't have to rewrite the questions. But if we look at this like recycling symbol, the question is it rotationally symmetric? So if we think about this arrow, if we were to turn it, can it map back onto this arrow or even the next arrow? And the answer is yes, it's rotationally symmetric. And because there's only 3 arrows in this image, we're going to be taking 360 divided by 3, which should be, let me just double check here so that I'm not doing my math wrong, every 120 degrees, or a turn on every 120 degrees. So in short, that's what line and rotational symmetry is. So after this video, when you come back to class, or maybe even later today after watching this video, you're going to answer some questions about if images have line symmetry or rotational symmetry, and then how many lines of symmetry or how many degrees, at what degrees is it rotationally symmetric. So that's all I have for you guys. Hopefully you can write this down in your little half sheet foldable, or if you didn't have it, like I said, hopefully you wrote it down in your notebook. But other than that, I want to thank you for taking good notes, and I'll see you soon.